let's take a look at the chain rule. Honestly, in my opinion, this rule is the best out of all of them. It's a lot like the power rule, right? When we're looking at composite functions. So I have a function within a function. G of x, right, is within, just like this chunk right here is within the parentheses that's to the fifth power. So it's kind of like we have f of x is x to the fifth, and then our g of x is that 5x to the fourth plus 6x, and that is just going to get plugged in for x instead. So it's composition of functions, one function within another. So you have to be able to pick out which function is what, right? So if there's a parentheses or if there's a square root, what's going on inside is the g of x. What's on the outside is our f of x. So we're always going to go outside in. So looking at h of x, we have this to the fifth power, right? That's what's stopping us first when we're taking the derivative. So when we're finding h prime, we're going to take that 5, just like the power rule, drop it down to the front as a coefficient. Then I'm going to write whatever's on the inside, that's going to stay exactly the same. Then I'm going to put it to the 5 minus 1 power. But I can't forget about what's on the inside, so that's why we have to also multiply by the derivative of the function on the inside. So derivative of the inside is 4 times 5, which is 20, to the x to the 4 minus 1, which is 3, plus derivative of 6x is just 6. And for me, for my classes, that's as simplified as I get because that's too much foiling for me. There's the derivative. When we're looking at h of x equals the square root of 5x minus 1, we see that we have our g of x, our embedded function, inside there. Our other function that's stopping us on the outside is that square root. So when we're finding the derivative, it's always best to take a root and change it to a fraction exponent. So I've got 5x minus 1 to the 1/2. Just like we did over in number 1, I'm going to take that 1/2, drop it to the front. I got 1/2, 5x minus 1 to the 1/2 minus 1 power. So when we subtract 1 from 1/2, we're actually going to start going into the negatives. So negative 1/2. Then I have to multiply by the derivative of the inside, which is just 5. Definitely simplify this if you can, right? Just make it cleaner. If there's a lot of foiling, don't do the foiling, but in this case, we can definitely clean it up. So this negative exponent means that it's not happy where it is. It wants to drop down to the denominator. So what's going to be in the denominator? Well, this whole chunk's going to be in the denominator, that 2 is going to be in the denominator, and then that 5 is in the numerator. So simplifying it, we get 5 over 2 times 5x minus 1. Now that it's in the denominator, our exponent turns to positive, and there's our derivative. This can also be written, right, if you like the square root look better, you can always stick it back in the square root. I'm not picky. Either one of those would be our derivative for number 2.